I will record. Okay, so it is recording, and then I'll put a YouTube link to it just in case. So we're just looking at past reactions. So we had an alkene, hydrogen palladium gave me an alkane, an alkyne, hydrogen and platinum or palladium, same thing, gave me an alkane. Alkyne, H2 and Lindlar's catalyst, that gives me an alkene. Okay. Now, like I said, it's not necessarily in order that we did it in. Let's see, adding our groups. So we've got um, okay, basically an alkyne. Step one, NaNH2. Step two, basically any R group with chlorine. Basically, you add the R group on. Now remember, an R group is basically, we'll say R is equal to basically any carbon chain. So any carbon chain. Any carbon chains are R group. Okay. Let's see. Then we've got, trying to post the order we did. Oh, so we also had the oh, we had, let's say this with an X on it plus zinc and HX. Yeah, it gives me, takes the X off, plus ZnX2. Okay, we got that. X is any chlorine, for the most part, chlorine or bromine. Okay. Let's see. Then we've got the, so let's look at some of the acid situations. Okay. We've got, say, carbon, double bond carbon. Let's see, like this. Okay. 1, 2. Okay. So we have this situation, all right? Basically, H3O plus. Okay. This gives us OH here, all right? Remember, it goes in the Markovnikov position. Okay. So that's the standard reaction here. H is really, so H2O, and H3O plus. Okay. Goes in Markovnikov position. Now, alcohols and acid, we talked about that also, right? So we have, go over here. So let's say alcohol, let's say a primary alcohol, concentrated H2SO4. The concentrated H2SO4 gives me this, right? And we have a secondary alcohol. We use H3PO4. Get this. And a tertiary alcohol. Tertiary alcohol. Use diluted H2SO4. Okay? And you get this. Okay. Right. Let's see. There. Let's go now to, oh, okay. Let's go to how to make um, branches across, or basically heligens across. We have an alkene, and we have uh, X2 in carbon tetrachloride. So X is either bromine or chlorine. You get C, C, and X is across. Okay, remember that in general. If we have and actually, and it works also for triple bonds. X2, CCl4. Okay. If you do a triple bond, then you get trans situation. Okay. Now let's look at our how to make a triple bond. Let's talk about that. So X here, X here. Now these are secondary. Remember, they're secondary alkyl halides, which these two are secondary. 2 moles of NaNH2. Okay. 2 moles of NaNH2. This gives you C, C triple bond, C, C. If you have any one of these as a primary situation, so let's say you have primary, these are both primaries, then you have to use what? Well, actually, there's a couple ways that you have to use, and let me do it like this. 2 moles of NaNH2 will do this, or 2 moles of KOH will also work here. So 2 moles of NaNH2 or 2 moles of KOH will work here also. This situation, you need 2 moles of a strong bulky base. O minus. So 2 moles of a strong bulky base. That will give you C triple bond C. Okay. Let's see. Let me clear this. Then we've got there. Cut. Let's cut some stuff. Okay. So we have C, C double bond CC. And we want to cut this, cut the double bond. There's 2 ways to do it. KMNO4, NaOH. Oh, I did forget something. I thought about it. Instead of cutting, let's just put OH across these bonds. KMNO4, NaOH, H2O, and cold. This makes a diol. So before, I forgot about that. Oops. OH here, and an OH here, a diol. There we go. Okay. Now let's cut it. Okay. So instead of a diol, let's say we want to cut the double bond. It's almost the same, except it's a little different. KMNO4, NaOH, H2O, heat. So this is step 1 kind of, and then step 2 on this, H3O plus. All right. This cuts it here and puts double bond O, OH on either end. Double bond O, OH. Okay. Another way of cutting is ozone. Step 1, O3, ozone. Step 2, acetic acid. Okay. I'm like I'm missing something, but okay, wait. Ozone, yeah. Um, so here we have C, C, double bond O. You make an aldehyde out of this instead of carboxylic acid. So C double bond O, H. I think it's zinc in this also. Praise that way. I think it's ozone, zinc, and acetic acid. I'll look it up. Can't remember offhand, but I think, yeah, I think, or I'm getting zinc mixed up with something else. But there we go here. Like I said, it's off the top of my head, offhand. I think it's ozone, but I think it's a zinc in here also. I'll check. All right, so we got this, these two, so this and this. Oh, now let's go into the free radical halogenation. All right, so free radical halogenation, regular standard alkane. Um, let's say CO2 in UV light. And the thing is, remember, the chlorine can go anywhere. A lot of times it goes in the anti-Markovnikov position versus anything else. But if you use bromine, Br2, in UV light, it goes in Markovnikov position. Speaking of which, let's go over the Markovnikov stuff. Let's see. We've got 1, 2, 3. Oops, let's do that. So, standard double bond plus let's say HBr, right? Standard addition to bromine is going to go either here or here, either one, because they're both secondary. So C, 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 Br, okay? If it was a tertiary situation, in HBr, then the bromine is going to go on the most substituted, which this is a tertiary carbon, it's a secondary. So C, 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 and Br here, okay? So Markovnikov. Now, if I wanted to go anti-Markovnikov, now this works with HBr and HCl, okay? The anti-Markovnikov, though, so in other words, I have this situation, and I want the bromine to be on the end versus over here. Then I do Br2, sorry, HBr. I do HBr and peroxide. Then I get C, 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 my bromine on the end, okay? All right. This is not including the standard stuff we learned about SN1 and SN2. So remember for SN1, SN2 reactions, we talked about that. So standard elimination, standard substitution. So if I've got something like this, Cl and plus what? If I do plus HF, C, 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 F plus HCl. This is a standard SN2 situation, okay? Elimination, sorry, SN2 substitution. I have this situation here where I have, let's say, 2, 3, 4, 5, Cl, I have this. plus CH3OH. Okay. This is going to be an SN1 situation. This is SN1. And you get 1, 2, 3, C here, O, CH3 here. Okay. Then we got good old-fashioned elimination one. Okay. So E1. I say let's do E2 first. Let's say I have this situation. Let's put the chlorine here again. No, put the chlorine here. Now this, to get elimination, I need to use a strong bulky base. O minus. Then I get 1, 2, 3. There we go. So this is E2. And then E1. Okay, E1. I can still use CH3OH, but I need what? Heat. I need heat here. So you cook it, then we get E1. 1, 2, 3, that. In this case, the double bond is going to go here because of ZCEF rule. Remember, ZCEF, anti-ZCEF rule. Okay, I think that covers all the ones for the most part that we did in Organic 1. I may have missed one or so, but I think that's it. That's just off the top of my head. So I'm sorry, this would be E1. Any questions? Okay, and like I said, I did record this, and I'll put it on, YouTube link, and I'll send it to you just in general in case we get other people that join in the ad drop. And I know we're missing one person. I'll let them know that at least. So this part was recorded. And as I said before, for the most part, this is where all the work is done. Most of you had me last semester. So we do all the work here. And then, quizzes every week. There's nothing else. So Wednesday, we'll actually start to work. Download those two sheets because you'll need those as we refer back to them. We're going to actually go do a little quick review over IR that we did last semester. Just make sure you're on top. Then we'll go right into NMR. If there's nothing else, I will see you Wednesday.